Hi, I'm Mike Stanzik and this is the Digital Electronics Classroom. So how does the number, or the three numbers, 3, 4, 5, how does that represent for us the number 345? Now that seems like a very simple question. I mean, 345 is 345. But where did that 100 come from? Where did the 4D come from? And why is it 5? And so this is something we want to investigate a little bit further to figure out other number systems like octal and hexadecimal. It's going to be really helpful for us. Therefore, stick around and watch this explanation before you move on to those other videos. Alright, so 3, 4, 5. First thing we want to understand for a decimal system is that the decimal system has what's called a base of 10. So it's based on the number 10. Okay? And it has 10 elements, 10 characters, if you will, inside that we can use to represent the numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And there is no 10. So there are 10 numbers here, but they go from 0 to 9. And those are the 10 numbers that are part of the base 10 system. Okay? And so when we are looking at a number like this, we've learned sort of the idea of place value. And so we put a place value with respect to this decimal point. And so we have 3, 4, and 5. And we've learned that this is the ones place. This here is the tens place. And then this here is the hundreds place. And so that's, kind of like, oh yeah, I remember learning that. So this is 3 hundreds, 4 tens, and 5 ones. That's 345. But what we probably haven't looked at is that 1, 10, and 100 are actually powers of 10. So this is 10 to the 0 gives you a 1. This is 10 to the 1 gives you a 10. And this is 10 to the 2, which gives you 100. So the ones place is a power of 0 on the base of 10. And then we have a power of 1 on the base of 10 and a power of 2 on the base of 10. So this idea of a base 10 starts to become a little more clear when we look at it in this fashion. And so that's where we get the place values, is the fact that they are powers of our base. 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3 if we go beyond that. And actually if we come to the right of the decimal point, we'll get 10 to the negative 1, 10 to the negative 2. So 1/10, 1/100th, and so on and so forth. But that is not our focus for today. And so when we look at the place values, so our 3 place values that we're looking at right here with respect to that decimal point, they have place values of 10 to the 2, 10 to the 1, and 10 to the 0, like so. But now we also have to think about the coefficients. So the coefficients, oops, lost it there for a second. Coefficients are the numbers that we use in those places. So we use the value 3 in the hundreds place, the value 4 in the tens place, and the value 5 in the ones place. So we have 3, 4, and 5. So 345. But let's look at the polynomial form. So this is actually how we're going to be writing this out. So 345, and I'm going to put these little parentheses around it and a 10 subscript, and that tells us that this is a base 10 number, and we're going to use 10 as our base in our polynomial. So now we take each of our coefficients and multiply it by the power that's associated with its place. So 3 times 10 to the 2 plus 4 times 10 to the 1 plus 5 times 10 to the 0. And then I can evaluate this. 3 times 10 to the 2 is 3. Oops, let's just go one more step, times 100. And let's go ahead and erase that. So 3 times 100 plus 4 times 10 plus 5 times 1 gives us 300 plus 40 plus 5, and eventually 345. Now this is still a base 10 number. So this is how 345 is equal to 345. Thanks for watching.